How many ways can you arrange the letters in the word math? Or, how many ways can you select 3 friends out of a group of 10 to form a team? Hello and welcome to Knowledge Heals. Today we are diving into Chapter 7 of the NCERT Class 11 Mathematics syllabus, Permutations and Combinations. This chapter is fundamental in understanding how to count and arrange objects in different ways, which has many real-world applications. Let's get started. The fundamental principle of counting is the backbone of permutations and combinations. It states that if one event can occur in m ways and a second event can occur independently in n ways, then the two events can occur in m into n ways. For example, if you have 3 shirts and 2 pants, the total number of different outfits you can wear is 3 times 2 equals 6. There are 6 different outfits. If you have 3 science books and 2 math books, the total number of ways to choose one book is 3 plus 2 equals 5. There are 5 possible ways. Permutations refer to the different ways of arranging a set of objects in a specific order. For example, the permutations of the letters A, B, and C are ABC, ACB, BAC, BCA, CAB, and CBA. Factorial notation, denoted as n factorial, is the product of all positive integers up to n. For example, 4 factorial is equal to 4 into 3 into 2 into 1, which is equal to 24. Permutations of and different objects. The number of permutations of indifferent objects taken ER at a time is given by P of nr equals to n factorial divided by n minus r. For example, the number of ways to arrange 3 out of 5 letters, A, B, C, D, E, is 5t, of 5, 3, equals to 5 factorial divided by 5 minus 3, which is equal to 60. Permutations of objects with repetition. When objects are repeated, the formula adjusts. For example, the number of permutations of the word balloon is 7 factorial divided by 1 factorial into 1 factorial into 2 factorial into 2 factorial into 1 factorial, which is equal to 1260. Let's solve a problem. How many ways can you arrange the letters in the word apple? 5 factorial divided by 2 factorial equals to 120 divided by 2, which is equal to 60. Combinations refer to the selection of objects without regard to the order. For example, choosing 2 friends from a group of 4 is a combination. The number of combinations of n objects taken r at a time is given by C of nr equals to n factorial divided by r factorial, n minus r factorial. For example, the number of ways to choose 3 students from a class of 10 is C of 10, 3 equals to 10 factorial divided by 3 factorial into 10 minus 3 factorial, which is equal to 120. An important property of combinations is C of nr equals to C of n minus r. This means choosing r objects from n is the same as choosing n minus r objects from n. Let's solve a problem. How many ways can you choose 2 fruits from a basket of 5 different fruits? C of 5, 2 equals to 5 factorial divided by 2 divided by 5 minus 2 factorial, which is equal to 10. Sometimes problems require both permutations and combinations. For example, how many ways can you form a committee of 3 out of 10 people and then arrange them in a line? First, choose 3 people. C of 10, 3 equals to 120. Then, arrange these 3 people. P of 3, 3 equals to 3 factorial, which is equal to 6. Total ways, 120 multiplied by 6 is equal to 720. Permutations and combinations are used in cryptography, lottery, scheduling, and even in forming passwords. Try solving these problems. 1. How many ways can you arrange the letters in the word statistics? 2. How many ways can you choose 4 students from a group of 12? 3. How many ways can you form a team of 5 from 8 boys and 7 girls if the team must have exactly 3 boys and 2 girls? Leave your answers in the comments. Complex problems. Let's solve a complex problem. In how many ways can you distribute 10 identical candies among 4 children such that each child gets at least one candy? This is a problem of combinations with restrictions. First, give each child one candy. Now, distribute the remaining 6 candies, C of 6 plus 4 minus 1, 4 minus 1, equals to C of 9, 3, equals to 9 factorial divided by 3 factorial multiplied by 6 factorial, which is equal to 84. Think about different approaches to solving these problems and share your thoughts in the comments. Today, we covered the fundamental principles of counting, permutations, and combinations. We learned how to apply these concepts to solve various problems. Stay tuned for our next video, where we will dive into Chapter 8, Binomial Theorem. Don't forget to like, share, and subscribe to Knowledge Heals.